scientific determinism, which he associates, you may remember, with Laplace.
Yes, that's right.
So this is a Laplacian determinism that goes back to Newtonian physics. How do you reconcile the affirmation of that kind of determinism with his view of quantum mechanics, which is indeterministic? This, to me, is a major contradiction that I frankly don't understand. And you can't try to escape it by saying that quantum indeterminacy only operates on the subatomic level, because it's easy to amplify those subatomic effects to have macroscopic results. For example, I heard of an amusing illustration of this. Imagine a student who's working in the laboratory one night on an experiment, and he's delayed in leaving the lab because of the decay of a radioactive isotope that he's working with. Well, that's a quantum indeterminate process. So he's delayed leaving the laboratory because it takes extra time to decay. As he leaves the laboratory, he runs into a girl in the hall whom he meets and eventually falls in love with and then marries. And so this quantum indeterminate event has major macroscopic results in the world. The fact is, you can't affirm scientific determinism if you're also going to hold that quantum indeterminacy is ontic rather than just epistemic.
Right, and of course the difficulty if you don't affirm at least the determinacy of event causation, in other words, the natural realm, if you don't affirm that, then it seems to me you can't have science work to begin with, because this little thing of experimental repeatability and all the things that are bound up with that requires that events follow themselves deterministically, at least apart from any agency intervening, and that's why science can do the work it can do.
Yeah, that's true, at least on the macroscopic level. Now, as I say, on the quantum level, because of this uncertainty principle, what you can predict are results within certain bounds. And you get a kind of bell curve, you know what I mean, of where it's most probable that your result will be found. But there is a definite indeterminacy on the quantum level that needs to be recognized, whether it's epistemic or ontic. That's a matter of interpretation.
Okay, fair enough. We're talking with William Lane Craig. He is giving us a little tutorial here to understand Stephen Hawking's new book, The Grand Design. Bill, back to this book here. I have a question that I'm interested in your response to, and it's a question that I would ask Stephen Hawking and others that are materialists, who talk about the laws of nature the way that Hawking talks about them, and he seems to be talking about them variably as deterministic kinds of things and other times as indeterministic kinds of things. But my question would be, are the laws of nature, these laws that you're talking about, Professor Hawking, are these merely descriptive or are they prescriptive? In other words, are the laws just summaries of the way things happen to have behaved in the past, or do the laws somehow actually govern things?
Yeah, this is an interesting question, and he actually talks a little bit about what a law of nature is, but he quotes a philosopher, John Carroll, and says this question is a lot more subtle than it at first appears.
Yeah, of course those philosophers are dead now, right? The philosophy's dead, right?
Yeah, right.
He doesn't need them.
They never really answer the question, but the working definition he seems to have is that he thinks of a law of nature as a rule that allows you to predict how things will happen apart from the observed behavior of a system. So I take it that he does think that these laws of nature have some kind of a prescriptive force, that they're not just descriptive, that they do have a sort of necessity about them that allows you to say, well, if the system were in such and such a state, this is what would happen.
Well, it seems to me that this raises a problem for him then, because as a materialist, what is the nature of these occult forces, these hidden powers that are lurking out somewhere? I don't know if they're in the material universe or not, but if they are laws that cause things to happen, what is the nature of those laws, and how does he square that with a materialistic account of the universe, and indeed what gives these laws, what grounds the force of these laws to begin with?
Yeah, I couldn't answer that for him because I don't think they addressed that question. As I say, the extent to which he discusses this is to say, here's what a law of nature is often thought to be. However, it's a lot more subtle and more difficult than this, and he gives a couple of counterexamples, and then he just moves on.
No, but
it's left unresolved.
From where you sit, would that create a problem for him to say that these are prescriptive forces? I mean, from a materialistic perspective, does that strike you as being inconsistent and also something that requires a grounding outside of the materialistic universe?
Well, I don't think that we have to think of the laws of nature being prescriptive as being forces. It seems to me that what he could say would be that there are certain substances in the world that have certain essential properties, and that determines their behavior. And the laws of nature have the sort of necessity they do because of the properties.
I see. So he's going to ground it in their properties. Okay. Well, that makes sense, at least as far as it goes. He although he has this deterministic view that he talks about in there, a scientific determinism, and he seems to think, and I know he was on Larry King the other night, and he made it fairly clear that his project is to show that because of scientific determinism, there is no need for God at all. So this is another declaration that God is now dead. No need. The law, physics is everything. I think is his comment.
Let's be generous here, or sympathetic to our interlocutor, Hawking.
Okay.
What he says is that God isn't necessary to explain the way the universe is. Now, that wouldn't exclude, Greg, having a moral argument for God's existence, or maybe an ontological argument for God's existence. I could imagine someone who would defend God on other grounds, but I doubt that Hawking is very open to those either. But at least his argument doesn't exclude that. The argument is limited to saying that you don't need God to explain the origin and the nature of the universe.
Yeah, well, I think you've identified a limitation of what he's able to do with his particular argument, but I take it that people like Hawking and Richard Dawkins, for example, they seem to be able, they make their argument, Dawkins in the area of Darwinian evolution, and they think that this particular explanation succeeds in their area, that this somehow becomes a more aggressive argument that God doesn't exist at all.
Well, I think that's certainly the case with Dawkins. In the God delusion, he concludes, therefore, God almost certainly does not exist. But I don't find Hawking enough making that mistake, at least. They seem to be much more tentative and just say, God isn't necessary to create the universe or explain the fine-tuning. And that's why I said it's not really any different conclusion than what was in A Brief History of Time, where he just says, what place then for a creator? But that would be consistent with, say, a moral argument for God's existence, though then that would be hard to square with his determinism.
Right.
How can you have significant moral choices and moral agents if we're determined in everything we do?
Right. So not only is rationality lost in determinism, morality is lost. I thought it was kind of ironic that, according to one reporter, and I think a colleague of yours, that we received the email of his assessment of the Larry King show, that Deepak Chopra, of all people, was the one who offered the most trenchant criticism of Stephen Hawking.
That was a bizarre interview.
I thought that was kind of ironic.
Yeah. I think that Hawking, I would love to know what he thinks about morality. I mean, we know what Dawkins thinks. Dawkins thinks it's all illusory, that there is no good, there is no evil. As he says, there's nothing but pitiless indifference. I wonder what Stephen Hawking thinks about moral values and duties and things of that sort.
He does make some reflections in there. He talks about why the universe is such a mess, or the human civilization is such a mess. So there's some hidden moral judgments that are in there. Let me move to the cosmological argument, because it seems to me this book is meant to take a shot at the legitimacy of the cosmological argument.
Definitely.
And you've done a lot of work there, and you can characterize it your way. I have a simple characterization of the cosmological argument. A big bang needs a big banger. That's a simple way of putting it, but the idea is that given that the universe began to exist, it had to have a cause. This is your Kalam characterization, and something doesn't come from nothing is the presumption there. An event doesn't, like the beginning of the universe, is not uncaused. So what is Hawking's strategy to circumnavigate here the implications of the Kalam or any other cosmological argument for that matter?
It's very, very interesting to read his exposition in this book about that, because it's a little bit different than Brief History of Time. He explains this model that he developed with James Hartle at UCSB out there in California that uses imaginary time for the initial segment of the universe, and this has the effect of sort of rounding off the beginning of the universe so that it's not like a cone that goes back to a point, a beginning point, but it's more like a badminton birdie that has a sort of rounded off southern hemisphere.
Mm-hmm.
And in this book, he is willing to talk about the South Pole of that southern hemisphere
mm-hmm.
as being the beginning of the universe, that this is where the universe originated and that this is the first point in time. It's just not a singularity, that's
mm-hmm.
all. But he is willing to call it the beginning of the universe. And so there's nothing in his model that is inconsistent with the universe having an absolute beginning.
Mm-hmm.
And in fact, he affirms it. And there's nothing in the model that explains why that South Pole point came into being
mm-hmm.
rather than just nothing. So when you read that section of the book, it leaves you still wondering, well, but why did this imaginary time regime come into existence? And they return to that question in the final chapter of the book, where he says that if the positive energy of the universe and the negative energy balance each other out, then the net value of the energy of the universe is zero, and therefore the universe can come into existence just out of empty space by a fluctuation of the energy that is in empty space.
Mm-hmm.
But you see, the problem with that as an explanation, Greg, is that empty space isn't nothing.
Mm-hmm.
He's talking there about the vacuum energy that fills empty space and says things can fluctuate out of this energy into material existence. And that empty space doesn't exist until the South Pole on his model is real, comes to exist.
Mm-hmm.
So, in fact, he hasn't said anything to explain why something exists rather than nothing. Mm-hmm. All he's done is explain that if you have an empty space filled with vacuum energy, that energy can fluctuate into a material
mm-hmm.
form.
Mm-hmm.
And that's all he's done.
So he hasn't, in a sense, he hasn't gone back far enough to the ultimate beginning, although something like an ultimate beginning from nothing for even that vacuum space is intimated by his model.
Required by it. That vacuum space doesn't exist prior to the South Pole on
mm-hmm.
his model.
Mm-hmm.
So in one sense, Greg, this is really a great help to the person who wants to argue for the cosmological argument, because it affirms an absolute beginning of the universe before which nothing
mm-hmm.
existed. He says there is nothing prior to that South Pole point. He said it's a meaningless question to ask what there was before, because it's the beginning of time and space. And he doesn't say anything about how this could come into being uncaused from nothing.
Mm-hmm. All
he talks about later is how when you have empty space filled with vacuum energy, the energy can fluctuate into a material form. And so really, it doesn't even address the fundamental issue raised by the cosmological
So when he
argument.
says, and I saw the quotations in different places and maybe on the interview, that the universe comes into existence spontaneously out of nothing. The key word there is nothing.
Yeah.
Because nothing doesn't mean nothing.
What he's talking about there, you see, is the quantum vacuum. When he says the universe fluctuates into existence or comes into existence from nothing because of quantum gravity, there he's talking, and he's very clear about this in the book. It's in the last chapter. He's talking about empty space, which is filled with this vacuum energy and is constant throughout the vacuum. And if the positive energy and the negative energy of the universe balance each other out,